Okay, the next section says match the graphs to the description of the relationship shown in the graph. So we have 3 statements and we have 3 graphs. So number 6 says the number of college classes taken and hours of free time. So if you think about this, as the number of college classes increases, are you going to have more free time or less free time? I know from experience that the more college classes you have, the less free time you have. So we know that as college classes go up, free time is going to go down, so it's going to have a negative slope, which means that this is B. The next one says the number of college classes taken and the cost of tuition. Now this one, if you take more college classes, the more you have to pay. So we have college classes going up and we have cost of tuition going up. So that would be graph C because this has a positive correlation. And then the next one, the number of college classes taken and the number of roommates. That doesn't have anything to do with how many classes you take or how many roommates you have. They're not correlated. So this would be A. So that's that section. The next one says describe the trend in the scatter plot by completing each statement. So if we look at number 9, this says as SAT score blank, college GPA blank. So if you notice, you have this dot here, this one, this one, this one, and a few down here. Overall, this kind of has a positive trend. It's not very steep. The line doesn't go up very fast, but it's still a positive trend. So as the not the ACT, the SAT, as the SAT increases, does the GPA go up or does it go down? As we move from left to right, the graph goes up. So as SAT score increases, college GPA increases because that's what it means to have a positive slope, that when one increases, the other increases. So this would have a positive correlation. The next one, the blank cups of coffee you drink, the blank hours of sleep you get. So if you were to draw a trend line on here, would you say that it's positive, negative, or no correlation? If we look at these points, they have a negative slope. They're going down. So as the number of cups of coffee increases, do you get more sleep or do you get less sleep? So the more cups of coffee you drink, the less hours of sleep you get, because that's what it means to have a negative trend or a negative correlation. Okay, now the last one, does this look like it has a positive slope or a negative slope? If I were to draw a trend line here, I would say it looks something like that. So we can see that this is a positive slope. So as the distance increases, the airfare also increases. And that makes sense. The further away you go, the more expensive it's going to be. If you fly to Europe, it's going to be like $1,500. If you fly to Las Vegas, it's like $150. So the cost of airfare increases as the distance from Baltimore increases. So that's what it means to have a positive and negative slope. Okay, the next section is about line of best fit, or our regression line. So we are going to we'll just go over 2 of these because we kind of went over it last time. And for this part, I'm going to use Desmos again. So I'm going to go to the Desmos app. Actually, I'm going to just split screen it. So I'm going to open this and then put this on this side. There we go. Perfect. So I'm going to copy down this table. So remember, we go to the plus sign, table, and then I'm going to type this in. So we have 0, 2, 3, and 4. Then we have 163, 149, 143, and 119. So I'm going to zoom this out so I can see my points. So right now, it obviously looks super negative, right? It's almost a straight line down. So we know that our correlation coefficient is going to be negative. We also know the slope of our regression line should be negative. So let's put that on there. Our regression line, remember, we do y1, and then we do the little tilde. That says it's approximately equal to, it's like we want it to approximate that line. So we have y1 is approximately equal to mx1 plus b. Once we put that in, you can see right here, this is our correlation coefficient. So last time when we were doing those regression lines, it also included the correlation coefficient. And as we can see here, it's negative 0.9409. That is a very strong negative correlation, which makes sense because the line, we already knew it was negative. If we look at our graph, we can see that the points are hardly off of the line at all, so that makes it a strong correlation. Then down here we have our parameters, which gives us our regression line. So for A on our worksheet, we're going to put the line of best fit. That's y equals negative 10.1 x plus 166.3. Remember, if it's 5 or above, we round it up. If it's 4 or below, we round it down. So since it's 166.25, the 5 rounds the 2 up to a 3. Okay, the next part says describe the correlation. So the correlation we know is negative 0.94. And if you just saw that correlation coefficient, you should automatically know that this is negative. Right, we know this is a negative correlation. But then we should also, I didn't want to grab that part of the 4. We should also say, is this strong, moderate, weak, perfect? Is it no correlation? This one, we should know that this is a strong correlation. So it's a strong negative correlation. And we can tell all of that just by looking at that correlation coefficient, which is R right here. Okay, the next part is asking us to predict. So sometimes in class I've said that our regression line is our prediction line, and that is because we can use it to predict what's going to happen later or predict what happened in the past. So this table shows the number of local softball teams for the years 1993 to 2003. Sorry, 1999 to 2003. So on our table, we know that this is 1999. 2 years later, that would be 2001. Then this is 2002 and 2003. Whoops. So we have 2003. And it's asking us to predict how many softball teams there were in the year 2000. So we know that 2000 is right in between. I'm going to make this a little smaller. So we know that 2000 is right in between 1999 and 2001. So what's right in between 0 and 2? We know that our x value has to be 1. And it also says years since 1999. So we know 2000 was 1 year since 1999. So we're going to plug in x equals 1. So we get y equals negative 10.1 times 1 plus 166.3. And something cool on Desmos, you don't even have to go to a different app or a different page to calculate this. You can just hit the plus sign, do expression, and type this in. And yeah, it'll graph it on your graph. It doesn't really matter. So we're going to put in 10.1 times 1 with parentheses. And you see down here in this gray box right here, it says that it's negative 10.1. But we have to add in our B value. So we have 166.3. And right there, it tells us that in 2000, there were 156.2 softball teams. So other than the fact that you can't really have a decimal for a softball team because you can't have 0.2 of a softball team, does this prediction seem reasonable for that year? If we look at our table, it should fall right in between 1999 and 2000. So does it make sense that 156.2 is right in between 163 and 149? I would say yes, that this prediction makes sense. And the reason is because it follows the trend. It makes sense that it seems like in 1999, they had a lot of softball teams, and then it started decreasing as the years went by. So that's part C. Now the other part is part D. So this says approximate the number of softball teams in 2020. So if you think about it, just logically, does it make sense that we use data from over 20 years ago to predict how many softball teams we're going to have this year? It kind of seems like the data is out of date. It might not be the best prediction, but we'll see what we get for our equation. So if the year is 2020, how many years has it been since 1999? It's been 21 years, right? Including 1999. So we have 21 years, and that's what our x is. So we have y equals negative 10.1 times 21 plus 166.3. And that's going to tell us how many baseball teams this data predicts there will be this year. So instead of having to type all that in, I'm just going to go over to my Desmos, delete the 1 here in the parentheses, and type in 21. Super easy. So this gives us a y value of negative 45.8. So I want you to think about that. Does that make sense for a number of softball teams this year? Can you even have a negative number of softball teams? That doesn't make any sense. So no, this prediction makes no sense. It's not reasonable at all because you can't have a negative amount of softball teams. Plus, like I said, the data was from 1999 to 2003. That's a long time ago. It wouldn't make sense to use that data to predict what happens, 21 to 17 years later. It doesn't make sense. So my answer here is no. Okay, we're going to do one more example on the back, number 13. This table shows the weight loss of a person over time. So this shows how many weeks since they started trying to lose weight and what their weight loss or what their weight is as it fluctuates. So I'm going to go on here and I'm going to delete all this stuff on Desmos because we don't need it. So now I'm going to put in a table just like we do when we want to put on a scatter plot because we need x and y for points. So we have 0, 1, 3, 5, and 7. Those are our x values. That's the weeks that they've been losing weight. And then we have 219, 214, 216, 205, and 199. So as you can see on my graph, we can barely see one of the points. So I'm just going to pull this down and I'm going to zoom in a little bit so we can see those points better. So looking at this graph, I want you to think about how you would describe the correlation without even knowing the correlation coefficient. What would you describe it as? Is it positive? Is it negative? Strong, moderate, weak? Is it perfect? Is there no correlation? So on this one, if we were to draw a trend line or our regression line, we can see that it would be decreasing. So we know that this is going to have a negative correlation. But do you think that this would be strong, moderate, weak, or perfect? We can see the points don't fall exactly into a line. So we can't say that it's perfect, but the points are going to be pretty close. So I'm going to say that this is a strong negative correlation. And then we'll see what the correlation coefficient says on the next one, or on the next part. So remember, when we want to put the regression line on there, we say y1, and then we don't do equals because we don't want it to, we're not telling it what the line is, we want it to approximate it. So we're saying y1 is approximately equal to mx1 plus b, and that pops up with all of our information that we need. It gives us the correlation coefficient and m and b. And the cool thing about Desmos is that you can use this on end-of-level testing. So if you know how to use Desmos on the computer, then you'll be awesome on the end-of-level testing that happens in May. And you can also use the TI Nspire, so it's good to know how to use different types of technology to do things. So the line of best fit here we know is y equals negative 2.7x plus 219.3. Because this is our m and this is our b. And we already said that it would be a strong negative correlation. Now we can look at the correlation coefficient and see if that makes sense. It would be negative 0.94, which is the same as what we had for our other one, which we said was a strong negative correlation. So it makes sense. And as you can see on our graph, the points don't fall very far off. We also don't have that many data points. So it's, for the data points that we have, it's a strong negative correlation. But maybe if we had days instead of weeks and their weight fluctuated more, then maybe it could be a moderate correlation or a weak correlation. But we're not, that's what we're going to say based on the data we have. So C says approximate the weight of a person after week 6. So remember, weeks, that's X, the weight, that's our Y. So if we have weight, or if we are looking at 6 weeks, that just means that X is going to be 6. So we have Y equals negative 2.7 times 6 plus 219.3. And like I said, we can just type that into this part, like on the next line in 3 on Desmos. So I'm going to do negative 2.7 times 6 plus 219.3. So that tells us that after 6 weeks, the weight loss of this person would be 200, well, the weight, we could calculate how much they lost, but the weight of this person would be 203.1. So looking at our graph, week 6 would be right here. Okay, so right here is week 6. Does it make sense that their weight would be 203.1? Going from 205 to 199? That makes sense to me because it follows the trend. It's decreasing with the exception of this part right here. And you can see that on the graph. So over here, these 2 points right here, they're off of the graph. They don't quite fit. So they don't quite fit the pattern, but it's not enough to make it so that it's not a strong correlation. So yes, this right here, it's kind of weird. We can see it on the graph, but if we're using the graph and we're saying, yeah, on week 6, it should be 2.3 or 203.1, it would make sense. Okay, part D, this one says approximate how many weeks. Remember, weeks is X. So we're trying to find how many weeks it will take for the person to reach the target weight of 180 pounds. So weight, we said, is Y. So we haven't really done many problems like this, but we have solved equations before, so this shouldn't be too hard. So instead of having X and solving for Y, now we have Y and we're solving for X. So we're going to say 180, which is Y, equals negative 2.7, man, I am struggling with this part. Okay, negative 2.7x, because we don't know what x is, plus 219.3. So when we're looking at an equation like this, how in the world do we solve this? We're trying to get x by itself. So what do we do first? We would subtract the 219.3 first, and I'm going to type that over here on Desmos. So we have 180 minus 219.3. That tells us that it's negative 39.3, and those two cancel, so we have negative 39.3 equals negative 2.7x. Now remember, if we're trying to get this x by itself, we need to get all of the numbers away from that side. So what we do here is we just divide by negative 2.7. So we have x equals, and I'm going to go down to another one. We have negative 39.3 divided by negative 2.7. And right here it says 14.555555 forever, right? It's going to say 5 forever, but the last one they rounded up to 6. So we're just going to say it's 14.6. So if you were this person and your target weight was 180 pounds and you were losing weight like this person did, it would take you 14.6 weeks to get there, which that sounds pretty reasonable to lose like 40 pounds, 14 weeks. That's pretty quick. So I would say, yes, this is reasonable based on the trend. Okay, if you would like to do the last 3 as practice, you are welcome to, but I feel like we've gone over this enough and you had an assignment on it already. So your assignment this time is going to be about correlation. And then I also have another video posted that's about causation. So it's going to go over correlation versus causation. So correlation, we've talked about that a bunch. That's where you have points that are by a line like this. And this could be like height and weight, where if the height increases, your weight usually increases. Causation is something like miles in a car and the gas used. So this would also have a positive correlation because the more miles you drive, the more gas you use, but it's also causation because the more you drive, the more gas you use, and that's what causes the gas to increase. So she's going to go through lots of examples of causation and correlation. So pay close attention to causation because you have a couple of questions on your assignment that say, is this just a correlation or is it causation? So pay attention to the examples that she uses and make sure that, just make sure that you're paying attention to the examples she uses and try to understand the difference between causation and correlation. Okay, you guys are doing awesome.